Let's define some terms first. So the first one is an arithmetic sequence. It is a list of numbers with a definite pattern. Also, it is a sequence made by adding the same value each time. Common difference, also denoted as small d. It is the constant difference in all pairs of consecutive or successive numbers in a sequence. The third one is arithmetic means of an arithmetic sequence. Those are the number or numbers between two terms in a sequence. Lastly is arithmetic series. This is the sum of the terms of an arithmetic sequence. Now let's proceed to our example. We have 12, 16, 20, 24, 28, 32, 36, and so on and so forth. Notice that if we subtract 12 by 16, we get 4. 20 minus 16 is also 4. 24 minus 20 is equals to 4. 28 minus 24 is also 4. Now, since they have a constant difference, because every time I subtract two consecutive terms of the sequence, I get the same answer. Meaning, this sequence is what we call an arithmetic sequence. So this sequence, this kind of pattern, is what we call an arithmetic sequence. Now, what do you call this for? This is the constant difference, or simply the common difference, also denoted as small d. Okay? Now, how about the sequence? Do you think it is an arithmetic sequence? If you say yes, then you are correct. Let's see why. 20 minus 25 is negative 5. 15 minus 20 is negative 5. 10 minus 15 is negative 5. 5 minus 10 is negative 5. Obviously, all difference is negative 5. Therefore, they have a constant difference, or they have a common difference. So if this sequence have a common difference, therefore, it is an arithmetic sequence having a common difference of negative 5. In conclusion, if a sequence of numbers has a common difference, it is an arithmetic sequence. Vice versa, if a sequence is an arithmetic, meaning it has a common difference. Okay? Also, if the common difference is positive, or positive number, then the sequence is increasing. While if the common difference is negative, it is decreasing. Let's see in these two examples. The first sequence, the common difference is positive. That's why this sequence is increasing. While in the second, our common difference is negative. That's why the second example is decreasing. Now let's label all terms of the sequence. The first term can be denoted as a sub 1, second term a sub 2, a sub 3, a sub 4, and so on and so forth. In general, a sub n can be read as a sub n, of course, a sub n, where n is the number of terms. So if we see a sub 6, meaning this 32 is the sixth term of the sequence. A sub 5, meaning 28, is the fifth term of the sequence, and so on and so forth. So let's proceed. The second example, we have a sub 1 up to a sub 6, and so on and so forth. Now, another thing to notice is this kind of pattern. This is 12, just copy the bring down. We have a sub 1. 16 can be written as 12 plus 1 times 4. 20 can be written as 12 plus 2 times 4. 24 can be written as 12 plus 3 times 4, and so on and so forth. Now, what is 4 in this sequence of patterns? What is 4? Still remember what is 4? This 4 is called the common difference. Now, this 12 is the first term. So, meaning, each term of the sequence can be written as our first term plus something times the common difference. Now, what is this 1, 2, 3, 4, and 5? Notice that if we have in the second term, if this is 2, this is 1. Third term, this is 2. Fourth term, this is 3. 5, this is 4. 6, this is 5. So this number, the number that is multiplied by the common difference, is 1 less than the number of terms. So let's see if this is true to the other sequence. 25. 25 plus 1 times negative 5. Again, negative 5 here is our common difference. This is 1 because this is the second term. So 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. 5 minus 1 is 4. 6 minus 1 is 5. And so on and so forth. So in general, every term of an arithmetic sequence can be written using only the first term and its common difference. So let's see how. So a sub n, or also known as the last term or the nth term, can be written as first term plus, stop for a moment, if this is 3, the third term, and this is 2. If this is 4, this is 3. 1 less than. If this is 5, this is 4. If this is n, what is this number? Again, this is 1 less than. That's why it is n minus 1. And multiply by our common difference. There you go. This is the general formula for an arithmetic sequence. A sub 1 here is our first term. The d is the common difference, while n is the number of terms. So if we want 6th term, this guy, 6 minus 1, will become 5. If we want 20th term, this is 19. This will become 19 because 20 minus 1 will give us 19. Let's try to answer some examples of an arithmetic sequence. Sample number 1. Find the equation of the general term of the given arithmetic sequence, this one, 7, 10, 13, 16, and 19. So we need to find the general term, and also we need to calculate its 100th term. So let's start. We need to find first the equation for the general term of the sequence. Solution. First, we need to find the common difference by subtracting second term to the first term. Also, we can do this by subtracting 16 to 13, or the fourth term minus the third term, and so on and so forth. Usually, common difference can be computed using a sub 2, or the second term, minus our first term. In general, we can solve for common difference by using the formula a sub n minus a sub n minus 1. So in our case, we will use the second term 10 minus the first term 7. So 10 minus 7 will give us 3. So the common difference is 3. Let's see if this is true. 10 minus 7 is 3, 13 minus 10 is 3, 16 minus 13 is 3, 19 minus 16 is 3. So we have the common difference. Now, using the general formula for arithmetic sequence, we will find the equation for the general term. So let's substitute all the given values. So we have a sub 1, we have 7, and common difference we have 3. So we substitute 7 to this a sub 1 or the first term, and 3 to this letter D or the common difference. So we have a sub n equals to a sub 1 becomes 7 plus n minus 1 times 3. D becomes 3 because D is equals to 3, or the common difference is equals to 3. Next is to simplify this. So we have a sub n is equals to 7 plus 3 times n minus 3. So distribute 3 to n minus 1. 3 times n is 3. 3 times negative 1 is negative 3. Next is combine similar terms. So 7 minus 3 will give us 4. So we have a sub n equals to 3n, bring down, plus 4. Therefore, the equation for the general term is a sub n equals to 3n plus 4. Now, we are ready to calculate its 100th term. So, using the general formula for this sequence, a sub n is equals to 3n plus 4. Now, if we want the 100th term, we use n is equals to 100 because we want the 100th term, or a sub 100. So let us substitute n is equals to 100. A sub 100, or the 100th term, is equals to 3 times 100, n becomes 100 plus 4. Simplify. A sub 100 is equals to 3 times 100 is 300 plus 4 becomes 304. Now, another solution is by using the general formula for an arithmetic sequence. So, the formula is a sub n equals to a sub 1 plus n minus 1 times d. We got the same answer if we use this formula. Let's see. In this formula, we have a sub 1, or the first term. We also need the common difference. A sub 1, first term, and the common difference. And we know n if we want 100th term, so this n becomes 100 because we want the 100th term. So let us substitute all the given values to this equation. Let's see if we get the same answer as 304. So we have a sub 100, or the 100th term, is equals to a sub 1 becomes 7 plus n becomes 100 minus 1, d becomes 3. Now simplify. A sub 100 is equals to 7 plus 99, 100 minus 1 is 99, times 3. Simplify again. A sub 100 is equals to 7 plus 99 times 3 is 297, plus 7 will give us 304. So two solutions give us the same answer, 304. Therefore, the 100th term of this sequence is 300. Let's continue to arithmetic mean. Recall the definition of arithmetic mean on day 1. So what is arithmetic means? Arithmetic means of arithmetic sequence are the numbers between two terms in a sequence. Consider the sequence 10, 20, 30, 40, 50, 60, and 70. It is an arithmetic sequence because 20 minus 10 is 10, 30 minus 20 is 10, 40 minus 30 is 10, and it has a common difference of 10. That's why this is an arithmetic sequence. Now, Where's the arithmetic mean? So arithmetic mean are the numbers 20, 30, 40, 50, and 60 because those are the numbers between 10 and 70. So very easy. Arithmetic means are the numbers between two terms in a sequence. Okay. So let's have an example regarding arithmetic means. Number 1, find all terms in between. So in between, again, we're talking to arithmetic means. Between the first term, -8, and the seventh term of 10. In other words, find all arithmetic means between the first and the seventh term. Now, since we're dealing with 7 terms, we need to have 7 spaces. So make sure this is 7. 1, 2, 3, 4, 5, 6, and 7. This is the first term, so this is -8. And this is the seventh term, so this is 10. Now, for us to fill in these gaps, we need to solve for the common difference using the general formula for arithmetic sequence. So this is the formula again. A sub n equals to a sub 1 plus n minus 1 times the common difference d. Now let n is equals to 7. The question is, sir, why 7? Because we're dealing with 7 terms or 7 numbers. Okay? So plug in 7 to all n's. We have a sub 7, n becomes 7, equals to a sub 1 plus this n becomes 7 minus 1 times the common difference d. Now, a sub 1 is -8, so we can replace a sub 1 by -8. Also, a sub 7 is 10, so we can replace a sub 7 by 10. We have 10 is equals to -8 plus 7 minus 1 is 6, then times d. Simplify. Add 8 both sides. So we have 18 equals to 6d. This -8 plus 8 is cancelled out. Next is divide both sides by 6. This becomes 18 divided by 6 is 3 is equals to 6d divided by 6 is just d. So we have the common difference of this arithmetic sequence is 3. Now, solving for the remaining terms using the general formula for arithmetic sequence. Let n is equals to 1 to have the first term. Like this. Let n is equals to 2 to solve for the second term. And keeps going. Let n equals to 3 for the third, 4 to the fourth, 5 to the fifth term, until we reach a sub 7 or the seventh term. Now simplify this. We have 1 minus 1 is 0, times 3 is 0, plus -8 is -8. And keeps going. 2 minus 1 is 1, times 3 is 3. 3 plus -8 is -5. And so on. -2 followed by 1, positive 4, 7, and positive 10. Now notice, from our given, we know that the first term is -8. We get the first term as -8, as expected. And the seventh term is equals to 10. So to fill the gaps, the second term must be -5. The third term is -2. Next is 1, followed by 4 and 7. So therefore, the arithmetic means between -8 and 10 are -5, 2, -2, 1, 4, and 7. And that's it. Now, for more examples, open your book on page 20 to 21. Now, let's try if you understand the example by answering what is it. Get your notebook and answer the following. Find all arithmetic means between the given terms. As always, solution for number 1 is provided, and this will serve as an example for you. Number 1. Given a sub 1 is equals to negative 3 and a sub 6 is equals to 17. So we're dealing with 6 terms. Solution. So we need to have 6 lines or 6 spaces. So 1, 2, 3, 4, 5, and the last one is 6. Okay. And the first term goes here, negative 3. The sixth term goes in the last term. Now, using the general formula for arithmetic sequence, we have a sub n equals to a sub 1 plus n minus 1 times d. Now, let n is equals to 6. Why 6? Because we're dealing with, very good, we're dealing with 6 numbers or 6 terms. Okay. Next, so plug in n is equals to 6 to our formula. We have a sub 6 is equals to a sub 1 plus 6 minus 1 times d. Next, a sub 6 is given 17 and a sub 1 is given is negative 3. So we can substitute those numbers. So we have 17 equals to negative 3 plus 6 minus 1 is 5, then times d. Next, add 3 both sides. Negative 17 plus 3 becomes 20. Negative 3 plus 3 is 0. Bring down 5d. Now, divide both sides by 5 becomes 20 divided by 5 is 4 equals to 5d divided by 5 is just d. Therefore, the common difference of this arithmetic sequence is positive 4. Now, to fill in the gaps, we need to solve for the second term, third, fourth, and fifth term. So, using the general formula for arithmetic sequence, and by using this common difference of 4, we can now solve the first term up to the sixth term by replacing n is equals to 1 for the first term, n is equals to 2 for the second term, until a sub 6, n is equals to 6 for the sixth term. Okay, now simplify those numbers. For a sub 1, 1 minus 1 is 0 times 4 is 0. 0 plus negative 3, we have negative 3 as expected again because a sub 1 is given negative 3. Next, simplify more. Simplify lang, simplify until we reach a sub 6 or the sixth term. We have 17. Now, another way to solve for these numbers 1, 5, 9, 13 is just adding this 4 common difference to our first term. Okay, let's try. Negative 3 plus 4, the common difference is 1, plus 4 again is 5, plus 4 again 9, 9 plus 4 is 13, 13 plus 4 is 17. So, 1, 5, and 9 are our answers. So 1, 5, 9, and 13. Therefore, the arithmetic means between negative 3 and 17 are 1, 5, 9, and 13. Okay? Let's have arithmetic series. Now, recall the definition of arithmetic series on day 1. Arithmetic series is the sum of all terms of an arithmetic sequence. Now, again, consider this example. We have 10, 20, 30, 40, 50, 60, 70. My favorite example. Taking the sum of the terms we have, because we want the series or arithmetic series, so we need to take the sum of all those terms. Consider our example, 10, 20, 30, 40, 50, 60, 70, my favorite example. Now, taking the sum of all terms, we have 10 plus 20 plus 30 plus 40 plus 50 plus 60 plus 70. Because we want arithmetic series, we need to find the sum of those terms of our arithmetic sequence. So we need to take the sum of the first term, second, third, fourth, fifth, sixth, up to 7th term. So add those together. Make sure that we get 280. Now, before you proceed, always check your answer using your calculator. So let's check. So we have 10 plus 20, just type in, plus 30 plus 40 plus 50 plus 60 and then plus 70, the last number, and then take equal sign, and we got 280. So make sure that your answer is correct before you submit to your respective teacher. Okay? So let's proceed. Therefore, we can say that the sum of its terms is 280. Now, in notation, in mathematics, there's a lot of notation. So, there's a notation for the sum. So, in notation, S sub 7, meaning the sum of the 7 terms of this sequence, or whatever sequence it is equals to 280. So, again, the sum of the 7 terms of in any sequence of this sequence is 280. Okay, so in general, should be S sub n. Now, if you don't want to add those numbers, like for example, we have 100 terms. So, we can use a formula to make it easier. So, we have two kinds of formula. So we have the first one, S sub n, or the sum of all terms, is equals to n over 2 times the quantity a sub 1 plus a sub n. The derivation of this formula is on your book, so just open your book and look for the derivation of this formula. Now the second formula is about S sub n is equals to n over 2 times the quantity 2 times a sub 1 plus n minus 1 times d. Now, these two equations are just the same thing. Okay? Don't worry, this is just the same thing. Now, wherein a sub 1 is our first term. So, obviously, a sub 1 is our first term. A sub n is the last term. This one is the last term. D is our common difference, and n is the number of terms that we want to add. Take time to memorize this formula. So let's proceed. Now, let's use this formula on our sequence and let's see if we get the same answer. So given, we have a sub 1 is equals to 10, our first term. The last term, we take a sub n because 70 is our last term, though this is a sub 7 or the 7th term, but still 70 is the last, so we have the last term, 70. Common difference is 10. 70 minus 60 is 10. 60 minus 50 is 10. All the way, the common difference is 10. So the common difference is 10. And n is equals to 7. Why 7? Because we have 7 terms. Okay? So let's proceed to our first formula. S sub n is equals to n over 2 times the quantity a sub 1 or the first term plus a sub n or the last term. Substitute all the given values in this formula. n is equals to 7, a sub 1 is 10, a sub n is 70. So let's do this. S sub 7, meaning the sum of the 7 terms, is equals to n becomes 7 divided by 2 times the quantity a sub 1 becomes 10, a sub n becomes 70. Simplify. S sub 7 is equals to 7 over 2 times 10 plus 70 becomes 80. Simplify again. So 80 can be divided by 2. So we have 80 divided by 2 is 40 times 70. We have S sub 7 is equals to 280. Now, 280 is familiar to us because this is our answer before. Now, to double check our answer, as always, we need to use our calculator. That's why we have a calculator. So let's see. Let us check. So let us check this formula. If this is also equals to 280. This is just a double check. So 7 divided by 2. Then we have a parenthesis here. We have 10 plus 70. 10 plus 70. Okay, and then hit equal sign. Make sure that we got 280. So we are correct. So let's proceed. So let's proceed to the second formula. How about if we use the second formula? So S sub n is equals to n over 2 times the quantity 2 times a sub 1, or the first term, plus n minus 1, the number of terms, times the common difference d. Substitute all the given values in our formula. We have S sub 7, n becomes 7, 7 over 2, n becomes 7 here, 2 times 10 because a sub 1 is 10, plus n minus 1, n becomes 7, times 10 because our common difference is 10. Let's simplify. S sub 7 is equals to 7 over 2 times the quantity 2 times 10, we have 20, plus 7 minus 1, we have 6, 7 minus 1, 6, and then bring down 10. Simplify again. S sub 7 equals to 7 over 2 times the quantity 20, bring down 20, plus 6 times 10 is 60. Simplify again. We have S sub 7 equals to 7 over. Now, 7 over 2 times 80 is familiar to us because in the left side we have 7 over 2 times 80. So they are the same, so meaning the answer is also the same. So S sub 7 here is equals to 280. Now, to double check our answer again, we need to use our calculator. As always, double check your answer before you submit it to your respective teacher. So, okay, so let's see. Using this formula, the long one, so we have 7 over 2 times the quantity 2 times 10, parentheses 10, plus 7 minus 1 times the quantity of 10, parentheses, and another parenthesis to enclose all those numbers inside, and then hit equal sign, and then make sure that we get 280. Okay, so let's continue. So therefore, we are very sure that the sum of our sequence is 280. Now, when to use this formula? Because we have two formula, when to use them? The first formula, here's your clue. If the last term is given, like for example, given the last term is equals to 200, you know the last term. Therefore, you need to use the first formula. If you don't know the last, like for example, you want to add first term, second term, up to 100 term, but you don't know what is that number, or you don't know what is the 100 term, so you will use formula letter B, or the second formula. If the last term is not given or not visible, or you don't know the last term, you will use this formula, the second formula. If the last term is given or the last term is visible, you will use this, or we will use this first formula. So